This is Henry Lieberman from the MIT Media Lab, and welcome to the fourth and final lecture about artificial intelligence in the General Systems Theory course. What I'd like to do in this lecture is show you some examples of how we use common sense reasoning to improve the behavior of interactive interfaces. And you remember the interface principles that we talked about in the previous lecture about trying to make fail-soft interfaces and trying to use common sense to anticipate what the user might want, sort of provide intelligent defaults. Okay, so we have a lot of different applications. We'll just have time to show you a few. The first one is GOOSE, Goal-Oriented Web Search, by my student Hugo Liu. And the idea is to add common sense to a search engine. What we noticed was that beginners who use a search engine often type their goals, not what we would consider search keywords. So what we try to do is use common sense to infer search methods from the user goals. And that way we can personalize search with context relevant to the goal. So here's an example of that. A person who's a beginner that doesn't have very much experience with search engines might type into a search engine, "Help me get rid of the mice in my kitchen." Okay. Now, a web search on mice kitchen is not a very good web search. Okay. What you want to do is recognize the fact that the person's goal in typing that is to get rid of the mice in the kitchen. And you want to combine it with a piece of common sense knowledge that says that an exterminator is a person who helps people get rid of pests. You might have to conclude that mice are pests and so forth. So out of all the 750,000 statements that we have in the open-line common sense knowledge base, one of them says that an exterminator or pest control helps you get rid of pests in your house. And mice are an example of a pest rather. So we can try to look at what the user is typing into the search engine, convert the query, "Help me get rid of the mice in my kitchen," to search for pest control. Okay. Not only that, but if we want to search for pest control, we realize that it has to be something local. And finding pest control in California is no good if you're in Cambridge, Mass. So we use the keywords pest control in Cambridge, Mass. And we're able to make that into an effective query for the user. Okay. If we don't have any information to understand what the user's goal is, then we simply forward it for the user's search engine, and the user is no worse off than if they used a traditional search engine. Another application I'd like to show you is called ARIA, Annotation and Retrieval Integration Agent. So we all have digital cameras now, and the digital cameras are great, but what's happening is that we all get 10 million files on our disk, all called image69.jpg. Okay, so the problem is we can't find anything that we have. Okay, but what we decided to do was understand that people often use digital photographs in storytelling. You send a letter to your friends or your family about some event, and you like to illustrate it with photographs. So we use the context of the message to infer the relevance of the photographs to some text that you're typing. We try to retrieve relevant photographs as the message is typed continuously, rather than wait for you to type in a query and use a search engine. Okay, and then we can also annotate photographs from relevant text from the message. And I'll show that in just a second with a demonstration. But one thing I want you to notice from this demonstration is that there's a streamlined interaction. So we don't have any dialog boxes, no file names, no cut and paste, no load and save, no typed queries, no multiple applications. And so we're basically saving the user a lot of work in this task that they otherwise might do. And so it's an illustration of how common sense and interfaces can make applications easy to use. Okay, here's a picture of the ARIA screen. On the left, you see a text editor that can be illustrated with photograph. On the right is a scrolling list of photographs that can have keywords attached to it. And then you see two big buttons at the top, send message and post web page. And the idea is you type in the left-hand screen, and the system is constantly showing you photographs it thinks might be relevant in the right-hand screen. Let's see a demonstration of that now. Okay, so here's a demonstration of ARIA. So I'm typing, "Hi, Henry," and we immediately get photographs that are tagged with the keyword Henry. Okay, say, "Last weekend, I went to Ken and Mary's wedding." Okay, and we get photos of Ken and Mary's wedding. That's just typing keywords. Okay, Ken and Mary's wedding was in San Francisco. It turns out we don't have any pictures that are tagged San Francisco, but we can scroll through the list and we can find a picture that shows Ken and Mary's wedding in San Francisco. So now we pick up that picture, we put it in the letter, and we see as a result of that, the picture is tagged. Who, Mary and Ken, where, San Francisco, where, Ken and Mary's wedding. Okay, and now this shows us some of the common sense background knowledge that we attach to the photographs. Since we said San Francisco, we know that it's in California, in the United States, Golden Gate Bridge. From wedding, we get happy and church and things like that. So the idea is we can know, using common sense, we can figure out a lot more about an image than is merely stated in the keywords. Okay, so in order to do this, ARIA is using natural language understanding, so it's picking out words like who, what, where, and it also does query expansion and temporal knowledge. So if you say last weekend, we immediately retrieve the photographs of the pictures that you took last weekend. Okay, another application I'd like to show you is GlowBuddy. And GlowBuddy is a dynamic phrasebook for tourists. So you're familiar with tourist phrase books like Berlitz that give you phrases to say in a foreign language at the restaurant or the hotel. But the problem with that is that they can't have every situation you might be in. So for example, you might want to say, I've just been arrested. Okay, that's probably not in your phrase book. Okay, so what we do is, instead of just translating the words, we go off to OpenMind, we extract concepts from the text, and we retrieve related common sense words and phrases from OpenMind, and then we push it through a translator. So if we ask OpenMind about the situation that you've just been arrested, we retrieve facts like, if you're arrested, you need a lawyer. Bail is a payment that allows an arrested person to get out of jail until a trial. Maybe if you're arrested, you should get your friends to bake you a cake with a file in it. The idea is that there you are, you've just been arrested, and now you know how to say lawyer and bail and all the important words in the foreign language. So let's show a demonstration of that. This is a demonstration of the GlowBuddy system, and we've implemented on Pocket PC computers and also on cell phones. And as you can see, it just has a simple dictionary function, okay? But also it can connect over the network to the OpenMind Common Sense Knowledge Base, or we can also store the entire Common Sense Knowledge Base on a memory card. And so the idea of putting an entire Common Sense Knowledge Base, foreign language dictionaries, on something as simple as a cell phone is possible now because we have enough memory and processing power to do it. Okay, and so now what you see is we found words like basket. If we type in picnic, we get picnic basket. Okay, we get picnic is a meal that takes place in the countryside. And now we get words and phrases. So we have a picnic basket attracts ants. Okay, well, you might not want to exactly say that, but at least it gives you some words and phrases and vocabulary to think about. Maybe perhaps you go into a hardware store and ask for ant repellent to have your picnic. Okay, so that's GlowBuddy, and then this is the implementation of GlowBuddy, again, on cell phones and Pocket PCs. Okay, now I want to show you a very, very simple application, but it's very useful, is just predictive text entry. So again, on cell phones, it's very difficult to type on cell phones. And many of you are familiar with word prediction software. So as you're typing, it tries to figure out what word you'd like to type next, and then it tries to complete it for you. But as you also probably know, some of those pieces of software are quite frustrating because it makes a wrong guess. Okay, most of that is relying on the frequency of words. So it tries the most common words in English or the words that you've most recently typed. So instead, what we do is try to look for completions that make sense in the context. So if you say, I am arriving at the train, and then you type an S, the logical completion is train station, even though station might not be the most common word that begins with S in English. Okay, so let's see an example of that. Okay, so this is the predictive text entry also running on a Pocket PC. And so we type TGA after tennis, and it says tennis game. TPL is player. Okay, and you can also see in the center box plan, place, and those guesses are wrong. But those are the guesses that the Microsoft software on the Pocket PC is making. We've also applied the same techniques to speech recognition. Okay. About 2 years ago, I myself was in a bicycle accident and I broke both my hands. So I was motivated to start learning about speech recognition. And we realized the same techniques could be used in speech recognition. And again, what we do is we let the speech recognition figure out the possibilities, and then we filter them through common sense. So if you say, my bike has a squeaky brake, did you mean B-R-E-A-K or B-R-A-K-E? Okay, and just from listening to the acoustics, the system can't tell the difference. Okay, but what we can do with common sense is we can go into common sense and say, what do you know about bikes? Bikes have handlebars, bikes have wheels, bikes have brakes. Aha, now we know which brake you're talking about. Let's see a demonstration of that. Okay, you can see that we got the right word brake in this example. Okay, and now we're going to go down to look at what the Microsoft Speech Recognizer had to offer, and it was going to choose the wrong brake. So how did we know the right brake? Well, here are some of the concepts that are associated with bike: tire, seat, wheel, pedal. Brake is farther down on this list. Okay, so now we see how we're able to use common sense to make better speech recognition. Okay, so with speech recognition, what we're also working on is trying to improve the correction interfaces. If you've used speech recognition in yourself, you know that one of the most frustrating things is the correction interface. If the speech interface gets the word wrong, then typically what it does is it displays a menu containing maybe 6 to 8 choices about what the word should be. Okay? And these are computed statistically. The problem, again, being that the system doesn't have any idea of what makes sense. So if you said tennis player, okay, and then the system types tennis slayer, well, that doesn't make any sense. But it could have been maybe tennis clay court. So words that sound similar but are different, okay? So the idea is that typically it would show you between 6 and 8 hypotheses. So if we can cut that down to 2 or 3, then you can have a different kind of correction interface. You can just have the system say, oops, and it can show you the next choice, rather than putting up a menu, having to read the menu and select something from the menu, which takes maybe 10 times as long as just saying the word. Okay, now I want to show you kind of a fun application that Hugo Reader did that was also very surprising, and that was computing emotional content of text. Okay, the idea is you want to take a piece of text and you want to say what emotion is that piece of text expressing. Okay, now you might imagine that you look for words like happy or sad in the text, and that when you can do that, that works. But there's also a lot of text where you don't explicitly use words like happy or sad, but it's easy for a human to recognize what emotion is being expressed. So, for example, if you say, I got fired today, then that's a pretty good guess that that was sad, a sad event. Okay. So what we do is, instead of looking up words like happy or sad directly in the text, what we do is look up those words in the OpenMind knowledge base. So we say, what in OpenMind is correlated with being sad? Okay. Maybe having no money is correlated with being sad. Okay. Why would you have no money? Well, if you get fired from your job, then you have no money. Okay. So in about 3 or 4 steps, we can go from getting fired to being sad. Okay. And then maybe just a few percent of the emotion, the OpenMind common sense knowledge base explicitly talks about happiness or sadness, but we can get it up to maybe 30% with just about 3 or 4 steps of this kind of inference. So let me show you a demonstration of that. Okay, so here we're typing, hi mom, guess what? I bought a new car last week. And the face on the side shows an expression of surprise. The car was a lemon. Okay, and now it turns to anger. So open mind has the knowledge that a lemon is a car that's always breaking down. And now you type a shiny red BMW. Okay, and you see it get surprised again. Okay, now, but I got into an accident with it, and I wrecked it. And that's sad. And that's shocking. Okay. So again, it's getting this from doing natural language analysis and then looking up at open mind to figure out what the emotional content of the text is. Okay, but here you say, I met my girlfriend by accident. Okay, and that's a happy event. Okay, so you can tell that's what it's doing is trying to understand the situation and not just working on the keyword accident. So again, we're doing affective classification of text. And we can also use this for affective visualization. So the stripes you see in the bottom of the slide are a visual representation of the emotional content of the story, the rise and fall of the House of Usher. Okay, and so what we're doing is color coding the various emotions involved. So maybe it starts out happy and there's some suspense, which builds up to, say, a shocking climax. And so this is kind of an interesting visual way of seeing the emotional content of a story. Okay, I just want to end by talking about a couple of projects that are underway now. One is Ashwani Kumar's iSeek, and the idea is that programs that give advice, like a financial advisor or a medical advisor, they have a model of the expert knowledge in expert systems, but they generally don't have a model of what the novice knows, okay? And so the idea is to use common sense as a generic novice model, and that allows a program that's doing financial advice, for example, to relate the expert model to the novice model. So if you go to the Vanguard site and they try to give you some advice on how to save for retirement, okay, and what they say is, what's your risk tolerance? But an ordinary person might not know what the technical financial concept of risk tolerance is. So a financial advisor might try to translate that into everyday knowledge. So they ask you, do you have debt on your credit card? Do you buy lottery tickets? They try to find everyday common sense activities that are associated with risk-taking behavior. Okay, so the relation between common sense knowledge and expert knowledge can be used for elicitation, where the expert asks the novice questions, and also for explanation. So an expert is trying to explain why they made some decision. They can do it by analogy to the novice common sense model. Okay. We're also looking at common sense for consumer electronics, Jose Espinoza. And we're worried about the problem that interfaces to consumer electronics now are getting more and more complicated: cameras, phones, stereo equipment. And there, it's a matter of mapping functions to controls. And traditional consumer electronics products are designed to map each function onto a control. But of course, the problem is that you get too many controls. So we're using common sense to try to fill in those gaps. Okay. So, for example, if you say, I want to listen to the news on my stereo, then it knows that the news is to be found on a radio and not on a CD player, and it could make the connections between the radio and the speakers automatically. Or you might ask it, why am I not hearing sound out of my speakers? And it might say, well, the possibilities might be the volume is too low or the input is selected wrong. So we're trying to use it to make consumer electronics interfaces easier. Okay, so I hope those applications give you just a taste of how we can actually use common sense knowledge to improve the behavior of interfaces even now. And it's very, very promising for the future. So in conclusion, I'd like to just bring it back to general systems theory a little bit. Okay, so like GST, artificial intelligence is an ambitious attempt to make a wide-ranging theory of systems. In the case of GST, we're talking mostly about physical systems or engineering systems or biology systems. In artificial intelligence, it's about the architecture of mental systems, okay? Like general systems theory, AI, of course, also has its skeptics and critics, but I hope some of the stuff that I presented to you gives you some ammunition against those critics. The connections between general systems theory and artificial intelligence are not only about neural networks, the way it's usually presented, but also techniques from cognitive approaches and top-down approaches, especially common sense, can be interesting and important. Okay. In particular, I want to impress upon you that a resurgence now of work in common sense reasoning holds a lot of promise for making new applications and new methodology in AI. So there are plenty of opportunities. I hope that at least some of you will be interested in pursuing this further and helping us do the research, because after all, it's only common sense. Thank you.